Can you tell us how did you become interested in cement and concrete science?
Well, it actually started at the undergraduate level. University I was at the student at, that was Krakow Technical University, had, like every university, variety of students' organizations, and one of them was sort of a club called Material Science of Concrete. And the mentor for that club was a professor who was teaching the class on building materials that I was a student in, and he mentioned that during the class, and I thought I would check it out. Found out that they meet once a month, that they participate in the little projects helping various professors, and that they write the papers based on those projects, and they also have sort of a self-study group that is led by the professor, and I got hooked. After about a year, I had the opportunity to present at the meeting of similar clubs from all over the country. A little bit later, we went and presented overseas, and I found it interesting and fascinating. So that's how it all started.
What does that mean to you to deliver the Delaroy lecture?
Well, delivering a Delaroy lecture is really a great honor. As I mentioned at the beginning of my presentation, I personally knew Della as a colleague when I was a young assistant professor here at Penn State. I also knew her before I met her in person as the founder and editor of Cement and Concrete Research, which I consider to be a very top journal in our field. So looking back, I would have never imagined that I would have the opportunity to deliver something that honors her legacy, and I'm really humbled and honored by that opportunity.
What do you enjoy the most about cement research?
I think that the most exciting part of doing that research is really versatility of scientific challenges that are associated with this particular material. Anything from fresh properties to the process of hydration and kinetics of the process, but also fact that the hardened product is exposed to so many environmental challenges that require us to address it on very different levels as far as the durability is concerned. It's a complex material that changes throughout the lifetime, and there's not that many materials that can match the complexity of it, which I think makes it challenging and interesting, allows you for implementing very practical approaches, but also it's very challenging with respect to modeling and prediction of performance. It also involves working very often in the multidisciplinary teams, forces you to get out of your area of expertise a little bit if you want to provide a meaningful contribution. So it has a lot of elements that are non-typical. That's why I like it.
So what do you think is the future of material science of concrete?
I view the shift in the approach, I view it as being associated in the shift with the approach that we are currently taking toward more computational based approaches. I think the complexity of the system itself and the challenges related to the application, real life application, are growing exponentially, and being able to tackle all of that experimentally is probably not realistic. Multitude of components that go into making concrete, multitude of admixtures, and various environmental exposure challenges that are associated with the utilization of concrete, I think will require a little bit more expanded predictive tools that are going to be associated with more of the modeling approaches than we currently have. As we are learning about some of the underlying chemical processes due to the availability of the more modern tools, I think the outcome of those evaluations will give us parameters that we can use a little bit more effectively in modeling. I remember many years ago, I have colleagues who were saying, a computer could never handle modeling of concrete because it's just too complex of the materials. The aggregates are not round spheres that we use to model the concrete with. Right now, we have the real shapes of the aggregates that we can use because of the computing power is so much higher. And I think our rate of success in being more realistic in predicting the performance is definitely higher, and I think it will be growing.
What do you like to do in your spare time?
What I like to do is really read something that is not technical. So I make a commitment that no matter how late it is, that I read for half an hour or an hour something that is totally not technical, either a novel or a historic novel. I'm interested in geography quite a bit, so I like to read material that is related to various geographical features or history or something like that. I also like outdoors activities. I like gardening, so I pull the weeds whenever I can, if needed, or go for a walk or something like that, enjoying the nature.
If you had to do it all over again, would you change anything?
I think that the only thing I would change is that I'll be a little bit more forceful in seeking mentoring opportunities. I think young professors are very timid and intimidated by older colleagues that are more experienced. But the reality is that you can move ahead much more effectively if you take advantage of the knowledge and experience of your colleagues. And I think, looking back, I could have been a little bit more proactive in talking to them and taking opportunities during the meetings like this to learn certain aspects of functioning in academia. And once you have that set of mind and try to take advantage of those opportunities, you will find out that those colleagues are actually quite happy to help and talk about how they view a path to success in academia. So I would encourage young professionals to do that not only in academia but also in the actual professional setting.